When you think of the guillotine, you picture the blade, that massive triangle of steel suspended in wooden guides waiting to fall. But there's something most people never notice. The blade isn't straight. It cuts at a precise angle, exactly 45 degrees in most models, sometimes steeper. This wasn't an accident, it wasn't aesthetic, and it certainly wasn't about making the device look more imposing to the crowds gathered in public squares across revolutionary France. That angle was calculated, tested, refined through trial and error, not by executioners seeking cruelty, but by physicians and engineers seeking efficiency. The guillotine has become a symbol of the French Revolution, of the reign of terror, of state power delivered swiftly and without ceremony. We remember the names: Louis XV, Marie Antoinette, Robespierre himself. We remember the spectacle, the crowds, the finality. But we forget that this machine was born from Enlightenment thinking, from the belief that execution should be rational, standardized, humane. The same minds that championed liberty and equality also designed a killing machine with mathematical precision. And that blade angle? It reveals something essential about how the state approached death itself during this period. It shows us the intersection of medicine, engineering, and political philosophy. It demonstrates how, even in the act of taking life, the revolution demanded order, predictability, and scientific method. This isn't a story about bloodshed. It's a story about control, about how a geometric decision, literally the angle at which metal meets flesh, became central to a system that would execute tens of thousands. So why exactly 45 degrees? Why not straight? Why not steeper or shallower? The answer lies not in sadism, but in physics, anatomy, and the disturbing logic of making death as efficient as possible. Before the guillotine, France had no standard method of execution. Your death depended entirely on your social class. Nobles were beheaded by sword, a relatively quick death when the executioner was skilled. Commoners were hanged, a slow strangulation that could take minutes. The worst criminals faced breaking on the wheel, where limbs were shattered methodically before death finally arrived. This inequality extended even to the moment of death. And by the late 1780s, as revolutionary sentiment grew, this discrepancy became impossible to ignore. Enter Dr. Joseph Ignace Guillotine, a physician and member of the National Assembly. In 1789, he proposed a radical idea. All executions should be carried out by the same method, regardless of class. Death should be equal, swift, and this mattered to him greatly, as painless as possible. Guillotine didn't invent the device that bears his name. Similar beheading machines had existed in Italy, Germany, and Scotland for centuries, but France would perfect it, systematize it, and deploy it on an unprecedented scale. The revolutionary government embraced the concept enthusiastically. Here was a machine that embodied their principles: equality before the law, efficiency, rationality. No more botched sword executions, no more executioners whose skill varied. Just a mechanism, consistent and impersonal. Dr. Antoine Louis, Secretary of the Academy of Surgery, received the commission to design the actual device. He worked with German engineer Tobias Schmidt to build the prototype. They tested it on corpses at a hospital, then on live sheep and calves. By April 1792, the machine was ready. The first execution took place on April 25th, a highway robber named Nicolas Jacques Pelletier. The crowd was reportedly disappointed. It happened too quickly. There was no drama, no struggle. But that was precisely the point. The guillotine wasn't theater, it was administration. The state delivering justice with mechanical certainty, and that angled blade was key to the entire system. Look closely at any historical guillotine, any diagram, any illustration from the period. The blade is never a straight horizontal edge. Instead, it descends at a diagonal. The cutting edge runs from upper right to lower left, creating that distinctive 45-degree angle. Some later models used even steeper angles, up to 60 degrees. This is immediately visible in the silhouette of the device. That slanted blade became iconic, instantly recognizable even in shadow. Political cartoons of the era often emphasized this angle, understanding instinctively that it was somehow essential to the machine's identity. But why would anyone design it this way? A straight blade seems simpler, more direct. Drop a heavy, flat edge onto a neck. Wouldn't that work just as well? Contemporary observers rarely questioned it. The guillotine simply looked that way. The angle seemed natural, perhaps even inevitable. Descriptions from the time focus on the height of the scaffolding, the weight of the blade, the speed of the fall. The angle goes unmentioned because it appeared self-evident. Yet nothing about the guillotine was accidental. Every measurement was debated, tested, refined. The height of the uprights, 14 feet. The weight of the blade and mouton combined, nearly 90 pounds. The width of the lunette opening, just wide enough for a human neck. These weren't arbitrary numbers. They were the result of careful experimentation, driven by a single goal: absolute reliability. The angle was part of this calculation. When Dr. Lewis and Schmidt tested their prototype, They tried different configurations. They observed how the blade interacted with tissue. They measured, adjusted, measured again. What they discovered was that the angle wasn't just important, it was critical. Without it, the entire system failed. To understand why, you need to understand the physics of cutting and the anatomy of the human neck. A straight blade dropped from height creates what engineers call a crushing cut. The entire edge contacts the surface simultaneously. All the force distributes across the full width of the blade. This works fine for soft materials, but the human neck isn't soft. It contains 7 cervical vertebrae, bones that are remarkably dense and strong. Surrounding these are muscles, ligaments, cartilage, and the tough outer layer of skin. A straight blade meeting this resistance can stall. The force dissipates. The blade might penetrate the soft tissue, but then jam against the spine. Historical accounts from before the angled blade was standard describe exactly this problem, blades stopping partway through, requiring the mechanism to be raised and dropped again. The angled blade solves this through a principle called progressive cutting. Instead of the entire edge striking at once, contact begins at one point and travels across the neck as the blade descends. Think of how you slice bread. You don't press straight down, you draw the knife across in a sawing motion. The angled guillotine blade achieves the same effect, but through geometry rather than motion. As the blade falls, the uppermost point of the angled edge makes contact first. This concentrates all 90 pounds of force onto a very small area. The blade begins cutting at this focused point. Then, as the blade continues its descent, the cutting edge progressively engages more of the neck. The initial penetration has already begun separating tissue, making it easier for the rest of the blade to follow through. The angle also creates a slight lateral force component. The blade doesn't just push down, it also draws slightly across the neck. This adds a shearing action that further aids the cut. The result? Clean, complete separation in a fraction of a second. No jamming, no multiple drops, no technical failure. Just physics, applied with terrible efficiency. The guillotine's efficiency served purposes beyond mere mechanics. It was a statement about the nature of revolutionary justice itself. Under the old regime, executions were events. They could last hours. The condemned might give speeches, priests would offer last rites publicly, the crowd would react and interact. The executioner was a performer, and his skill, or lack thereof, became part of the spectacle. The guillotine eliminated all of this. From the moment the condemned was positioned to the moment of death, 15 seconds, sometimes less. There was no time for drama, no opportunity for the condemned to become a martyr through a brave speech or dignified bearing, no chance for the executioner to fumble and create sympathy. The angled blade was central to this transformation. Its reliability meant the state could promise and deliver absolute consistency. Every execution, whether of a king or peasant, a general or a baker, proceeded identically. This uniformity was itself a form of power. The guillotine reduced individuals to bodies and death to an administrative procedure. The angle that made it work became, symbolically, the angle at which revolutionary equality met human mortality. Crowds gathered, yes. Executions remained public. But the nature of the spectacle changed. People came not to see a person die, but to witness the machine function. The guillotine itself became the protagonist. Contemporary accounts describe an almost hypnotic quality to watching the blade fall. That diagonal descent, perfectly predictable, yet somehow mesmerizing. The angle created a visual rhythm. The blade appeared to slice rather than simply drop. Some revolutionary leaders understood this instinctively. The guillotine didn't just kill efficiently, it killed in a way that emphasized the impersonal nature of revolutionary justice. You weren't being executed by another person, you were being processed by a system. And that angled blade was the system's cutting edge in every sense. The most persistent myth about the guillotine's angled blade is that it was designed to cause additional pain or to be more gruesome. This is entirely backward. The angle exists specifically to ensure the opposite: instant, complete severance with minimal chance of technical failure. A straight blade that jammed partway through would be far more horrific, requiring the blade to be raised and dropped again while the condemned remained partially alive. Another common misconception is that the angle was steepened over time to make the device more terrible as the terror intensified. In reality, angle adjustments were purely technical refinements. Some executioners preferred 45 degrees, others found 60 degrees more reliable with their particular apparatus. These were professional choices, not ideological ones. There's also a persistent belief that victims remained conscious for seconds or even minutes after decapitation, aware of their fate. While some 18th century physicians debated this, modern neuroscience is clear. The massive drop in blood pressure to the brain causes unconsciousness within 2 to 3 seconds at most. The angled blade's efficiency actually minimized any possibility of prolonged awareness. Some accounts claim the blade was deliberately dulled to make death slower. This makes no mechanical sense. A dull blade would be more likely to jam, requiring multiple drops. The The blade was kept sharp precisely to ensure single-stroke completion. Perhaps the strangest myth is that the angle was copied from medieval torture devices. In fact, as mentioned earlier, angled dropping blades had existed in execution devices for centuries before the French Revolution. What was new wasn't the angle itself, but the scientific approach to optimizing it. The guillotine's designers weren't seeking to maximize suffering. They were engineers and physicians seeking to minimize variables. The angle was a solution to a technical problem, not an expression of cruelty. The truth is more disturbing than the myths. They made death efficient because efficiency was the goal. Not every guillotine used the same angle, and the device itself evolved considerably across time and geography. The earliest French prototypes actually used a crescent-shaped blade, curved, not angled. Dr. Lewis initially believed this would be more effective. Early tests proved otherwise. The curved blade tended to push the neck downward rather than cutting through cleanly. The angled straight blade replaced it after just a few months. Regional variations emerged as the guillotine spread beyond Paris. Bordeaux's guillotine reportedly used a steeper angle, closer to 60 degrees. Lyon's executioner preferred a shallower configuration. These weren't official variations, but adaptations by individual executioners who adjusted the mechanism to their preferences. When other countries adopted similar devices, angles varied. The Italian Manea used a notably steeper blade, almost vertical at some installations. German states that employed falling blades before and after the Revolution generally favored the French 45-degree standard, having observed its effectiveness. The guillotine used in French colonies presented interesting cases. In the Caribbean, humidity and heat affected the wood of the uprights, causing slight warping. This sometimes altered the blade's descent angle unintentionally, leading to mechanical failures that required recalibration. Mobile guillotines, transported to different towns for executions, faced unique challenges. The angle had to be precisely reconstructed at each assembly. Experienced executioners carried measuring tools to ensure correct blade alignment, understanding that even a few degrees of deviation could cause malfunctions. After the Revolution, during the 19th century, the French government actually standardized guillotine specifications, including the blade angle. Official diagrams specified 45 degrees exactly. This standardization continued until France's last execution by guillotine in 1977. Interestingly, the German Fallbeil used during the Nazi period returned to a straight blade design with a much heavier weight. This proved less reliable, occasionally requiring multiple drops. The French angle, it seemed, had been optimal after all. The angle affected not just the condemned, but everyone involved in the execution process. For executioners, the angled blade meant reliability. Charles-Henri Sanson, Paris's chief executioner during the Revolution, oversaw thousands of deaths. His journals, later published, reveal an obsession with mechanical consistency. He describes testing the blade angle repeatedly, ensuring it met specifications exactly. This wasn't sadism, it was professional anxiety. An executioner whose guillotine malfunctioned faced public humiliation, potential violence from angry crowds, and official censure. The angled blade was his guarantee that the mechanism would work as designed. His reputation depended on that geometry. For the condemned, the angle likely meant little consciously, but everything practically. Those final moments, positioned face down in the lunette, staring at the basket below, what they needed was for the mechanism to work immediately and completely. The angle delivered that grim mercy. Guards and officials present at executions developed their own relationship with the device. Many accounts describe them watching the blade rather than the condemned. The diagonal descent became almost hypnotic, a predictable mechanical motion they could focus on instead of the human reality of what was happening. For the crowd, the angle contributed to the guillotine's almost theatrical quality. The blade's diagonal descent created a visual line that drew the eye, a geometric inevitability that spectators found compelling. It looked purposeful, designed, modern. This psychological dimension was never officially acknowledged, but it permeated the entire system. The angle transformed execution from a confrontation between executioner and condemned into a procedure involving a machine. This distancing, this ability to see death as a mechanical process rather than a human act, may be the angle's most significant historical legacy. It allowed ordinary people to participate in or witness mass execution without necessarily processing the human cost. The angle didn't just cut through necks, it cut through moral complexity. The 45-degree angled blade outlasted the Revolution by nearly 2 centuries. France continued using the guillotine until 1977 with the same basic design, including that distinctive angle. Why such persistence? Because it worked. Once the technical problem of reliable decapitation was solved, there was no reason to change the solution. The angle became standardized, institutional, unremarkable. This mechanical continuity across such different political eras, from revolutionary France to the Third Republic to Vichy to post-war democracy, reveals something important. The guillotine transcended the ideology that created it. It became simply a tool, its technical efficiency separating it from its origins. Other execution methods came and went. The electric chair, the gas chamber, lethal injection. Each faced technical problems, ethical challenges, prolonged debates. The guillotine just kept working, its angled blade still solving the same physics problem it was designed to solve in 1792. Engineers and historians studying historical execution methods consistently identify the angled blade as a key innovation. Modern forensic analysis confirms what 18th century testing discovered. The angle creates optimal conditions for complete, immediate severance. This has led to uncomfortable questions in medical ethics. The same principles that made the guillotine efficient apply to modern surgical instruments and industrial cutting tools. The knowledge gained from optimizing a killing machine has practical applications in saving lives and improving manufacturing. The angle appears in modern guillotine paper cutters, office tools that directly inherit the design. The name is used without discomfort, and that same 45-degree angle still provides the most efficient cut. Museums that display original guillotines find that visitors gravitate to examining the blade angle. Something about that diagonal edge, even inert and historical, carries a strange fascination. Its visible geometry, a problem solved, a question answered. The angle persists in our collective memory as the guillotine's defining characteristic, second only to its terrible purpose. So why did the guillotine have such a specific angle? Not for cruelty, not for symbolism, at least not consciously, not for aesthetics or to make the device more frightening. The angle existed because of physics, because of anatomy, because bone and muscle and skin resist a straight blade but yield to a progressive cutting action, because concentrated force at a point of contact is more effective than distributed force across a surface. The 45-degree angle was the solution to an engineering problem: how to ensure that a falling blade would completely sever a human neck in a single drop, every single time, regardless of the individual's size, muscle mass, or position. This reveals something essential about the revolutionary mindset, and perhaps about modernity itself. The same Enlightenment thinking that championed human rights also produced systematic execution. The same rational analysis that advanced medicine also optimized killing. The guillotine's designers genuinely believed they were creating something more humane than what came before. They weren't wrong, technically. A reliable, instant death is preferable to a botched execution. But they created a machine that made mass execution administratively feasible. That angle, that simple geometric choice, enabled a system that killed tens of thousands, not through malice in the design, but through efficiency. The angle didn't make the guillotine crueler. It made it more reliable, which made it more terrible. This is the obscure reason behind the angle, and the uncomfortable truth it represents. Sometimes the most humane technical solution serves the most inhumane purpose. Sometimes rational design enables irrational horror. The guillotine's blade was angled not because revolutionaries were sadists, but because they were engineers. And in the end, that might be the most disturbing thing about it. The angle was the answer to the question, how do we make death efficient? And that they asked that question at all tells us everything. Thank you for watching this exploration of one of history's most infamous machines. The guillotine remains a powerful symbol of the French Revolution, but understanding its technical details reveals deeper truths about how the state, efficiency, and mortality intersect. If you found this analysis interesting, please consider liking this video and subscribing for more historical deep dives into the obscure details that reveal larger truths. What other historical objects or practices hide unexpected explanations in their design? And let me know in the comments below. Until next time, remember, sometimes the smallest details carry the largest meanings.